We're on problem 135. I just did some Pilates, so I'm slightly out of breath. If x is less than 0, is y greater than 0? So if x is less than 0, is y greater than 0? All right, statement number 1. X over y is less than 0. X over y is less than 0. So this is actually pretty useful, right? They're telling us that x is a negative number, right? So we have a negative here, and we're dividing it by some other number, and they're telling us that that the resulting number is still negative. So we have a negative divided by something is equal to a negative. So I think you learned when you learned negative numbers, if y was negative, well, if y was 0, this would be undefined. And if y is negative, if this was a negative, then the resulting, when you divide a negative by a negative, you would have a positive. So y has to be a positive number, and it can't be 0. So this actually tells us, statement 1 alone tells us that y is greater than 0. Just based on the fact that you have a negative, that is just telling you that a negative divided by y is still negative, right? This whole thing is still negative, so y has to be a positive. Statement number 2 tells us y minus x is greater than 0, and that just tells us that y, let's see, add x to both sides. That tells us that y is greater than x. Well, that's not enough. It says if x is 0, is y greater than 0? X could be, maybe x is equal to minus 10 and y is equal to minus 9. So in this case, y wouldn't be greater than 0. Or maybe x is equal to minus 10 and y is equal to plus 9. Both of these would satisfy this condition. So we don't know. This doesn't tell us any information on whether y is greater than 0. So statement 1 alone is sufficient, and statement 2 doesn't do much for us. Problem 135. No, I already did 135. 136. 136. Okay, they've drawn a circle there, so I guess I'll draw a circle as well. So that's the circle. And they have, they have a center. The center goes up like that. And then looks like that, and there's a right angle right here. They call this O. They call this X. They call this Z. And then they actually connect those 2 points. They connect those 2 points. And then they call this point right here, that's y. Let's see what they're asking. What is the circumference of the circle above with center O? So they just want to know the circumference. So if we could figure out a radius, then we know circumference is 2 pi times the radius, and we'd be all set. So let's see what information they give us. Statement number 1. The perimeter of triangle OXZ is 20 plus 10 square roots of 2. Perimeter is equal to 20 plus 10 square roots of 2. Now, this is interesting. What do we know about this? Well, we know this is going to be an isosceles triangle. We know that if this length right here is x, that this length is also going to be x, because this is a circle. So a circle is, the radius is constant, right? And each of these sides are the radius of the circle. So those are both going to be x. And then what is this going to be? It's going to be, we just know from Pythagorean theorem, x squared plus x squared is going to be equal to that side squared. Is going to be, let's call that c squared. So you get 2x squared is equal to c squared, or c, and I'm calling this side right here c, is equal to the square root of 2. X times the square root of 2, whatever x is, right? So the perimeter of this entire triangle is going to be 2 x's, right? X plus x. So it's going to be 2x plus x square roots of 2. X square roots of 2. And statement 1 told us that this perimeter is equal to this right here. Is going to be equal to 20 plus 10 square roots of 2. Well, I think you could do a little pattern matching here and solve for x. I mean, this is actually, even though it might not look completely like it, this is a linear equation. And you can solve for it, and and immediately that should be, oh, statement 1 is sufficient, but you can just do a little pattern matching and say, well, this works when x is equal to 10. So actually, we are able to figure out what x is equal to, and then, as I said before, x is the radius of the circle, and then the circumference of the circle, which is the whole question is about, that's 2 pi times the radius. Circumference is 2 pi times the radius. We just figured out the radius is 10, so it equals 20 pi. So statement 1 is sufficient. What does statement 2 do? Statement 2, the length of arc xyz is 5 pi. xyz is 5 pi. So they're telling us that this length is 5 pi. That is 5 pi. Well, do we know what proportion that is of the entire circumference? Well, sure, because they tell us that this is 90 degrees right here, right? This is 90 degrees of 360 degrees of a circle. So this, the arc length right here, is exactly going to be 1/4 of the circle. And we know that because 90 degrees is 1/4 of 360. So 5 pi is going to be equal to 1/4 times the circumference, or that the circumference is going to be equal to 20 pi. So each statement independently, statement 1 or statement 2 independently, is sufficient to answer this question, the circumference of the circle. 137. What is the value of a to the 4th minus b to the 4th? A to the 4th minus b to the 4th. And immediately, just even looking, I mean, one thing I'm tempted to do is rewrite this as a squared squared minus b squared squared, because I just glanced at statement 1 and they had squareds there, so I'm going to do that, right? And you know that a squared, let me do different letters. You know that x squared minus y squared is equal to x plus y times x minus y, right? So here x is a squared and y is b squared. So this is going to be equal to, this is just the original a to the, this is going to be equal to a to the squared, a squared plus b squared times a squared minus b squared. And then we could simplify this again. So this is going to be equal to a squared plus b squared. We could simplify this as a plus b times a minus b. I think that's going to be helpful, just glancing at the two statements that they gave us. So statement 1 tells us that a squared minus b squared, a squared minus b squared is equal to 16. So that tells us that just this is equal to 16. That is equal to 16. That doesn't help me much because I don't know what a squared plus b squared is going to be. It just tells me the difference between these two squares. It doesn't tell me, and I don't know whether they're integers or anything. Statement 2 tells me that a plus b is equal to 8. And once again, that doesn't help me tremendously by itself, right? If I just know that a plus b is equal to 8, I don't know what a minus b is, I don't know what all of this is. But when I use them together, this is interesting, right? Because we know that a plus b times a minus b is equal to a squared minus b squared. Well, they just told us that a plus b is equal to 8. So a plus b is equal to 8. So 8 times a minus b is going to be equal to a squared minus b squared, which statement 1 told us was 16. So that actually tells us that a minus b is equal to 2. So now we have two equations with two unknowns, and we could solve for a and b. And if we can solve for a and b, then we can definitely tell you what a to the 4th minus b to the 4th is. And just to show you that, let me do it. So let's see, a minus b is equal to 2. Add these equations. 2a is equal to 10. A is equal to 5. And then if a is equal to 5, b is equal to 3. So our original statement, a to the 4th, is 5 to the 4th. 5 to the 4th minus 3 to the 4th. So whatever, that's what, 625 minus 81, I think. It doesn't matter. You can figure it out. So both statements combined are sufficient to answer this question. See you in the next video.